Welcome to this roundup. Over the years, many have wondered, can machines think? While many agree that someday thinking machines can exist, there are also some who says that thinking machines are already here. So, irrespective of whether thinking machines are here or not, what exactly is a thinking to machines? And do the machines think like humans, or does it simply control symbols it has no understanding of? Now, if machines do understand what they are doing, is it thinking? These the answer to all these questions depend entirely on perhaps how we understand thinking and consciousness in machines. But as we see, the term consciousness is itself caught in this endless explosion of meaning and debate, and there is no agreed central definition of consciousness either in humans or in machines. So it is perhaps time to evaluate the fundamentals of machine consciousness and understand whether do we really need to understand machine consciousness with reference to human consciousness. So to discuss fundamentals of machine consciousness further, I'm delighted to welcome Amol Kelkar to this roundup. Amol is a machine consciousness researcher and he's based in United States. Welcome, Amol. We are honored to have you on this roundup.
Thank you for having me here, Jayashree.
Wonderful, Amol. So as we know, computers perform computations. Now, since software powers the computers that makes anything, any machine that is embedded with any computer run on its own. So this raises the fundamental questions. Are machines thinking? Are they conscious?
Well, the AI algorithms of today, the ones that we use in industry or in research, they're not really thinking. They are performing computations such as approximating a function or predicting the next state of a system. These aspects look like intelligence and thinking, but they are actually imitations of thinking, if you will. Or, in other words, they are a subset of what we call human ability to think.
But imitation of thinking is a kind of thinking itself, right? I mean, why are we trying to relate machine thinking to human thinking? Because the way we think in and we analyze and all that is different. And the same, machines, they also analyze, they also think in a way, if you look at it, because when we ask question to Siri or Google that, hey, what is the temperature outside, or any other question, we do get an answer. And if they don't understand the question, they said, though, I don't understand this. So there is some thinking. Isn't there some thinking involved?
We can call it thinking. The idea would be to differentiate between an actual phenomena and a simulation of the phenomena. So, for example, if you look at fire, a real fire that is burning, and you simulate the fire in a computer. Now, both of them on the screen would probably look very similar, so similar that it might even be indistinguishable. But the simulation of fire is not really the fire.
Yes.
It's useful, like for example, in games, simulated fire and simulated water and simulated environments are used and useful, but they don't really represent the world as it is.
That's a fair point, but at the same time, understand this. Now, if we have the same kind of simulation in autonomous weapons or in autonomous cars, now it even though it's called just a simulation, but it still ends up either firing a missile or killing some human on the road. So that is the impact that we humans have when we go through these kind of activity. The similar response and result would be there when machines also go through certain simulations. So do you think that perhaps these I mean, as you are saying that this is like just a computation, machine intelligence is just a kind of computation. But this computation, what is it about this computation that makes it, thinking? What allows it to think? So when you are developing any algorithm,
Mm-hmm.
What do you define? How do you define what kind of, how do you define that any algorithm would respond in certain manner when certain question is asked? Because the algorithm is there, and then they will have a huge number of data set, irrespective of what task we are talking about, whether it's about researching cancer, or whether it's about driving a car, or checking the weather, or doing some kind of search on internet. So it could be any kind of task. So
Mm-hmm.
what is it that you define in the algorithm that would uh, give a command to the algorithm that I need to look beyond this, or I need to operate in certain way? What are the parameters? How do you define all that to make it sort of kind of like thinking?
Right. So the way modern artificial intelligence algorithms are built is based on the idea that once we can define an objective function, or a loss function as it is called in AI, once we can define how far away the output is from the desired output, then we can build algorithms to change the output of that model, tweak it slightly at each step so that it comes closer to what we expect it to be. So once we are able to define what specific intelligent behavior we expect from the algorithm, then the algorithm is able to adjust itself, or adjust the model to arrive at that.
I
The
think,
the
yes.
the 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 crucial interesting difference though is that we are doing the defining of what the intelligent behavior should be, versus 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 the way we think. Nobody is actually defining what each step or each objective is for us. So the idea of going beyond the traditional AI aspects is to think about ways in which intelligence can emerge rather than be specified in the algorithms.
Yes, no, I understand that. Now, emergence of intelligence, or emergence of thinking, or emotion, or consciousness. I mean, there is a blurring boundary between all of that. So let's assume that there is no consciousness, or there
Mhm,
is no thinking, and
mhm.
that the thinking that we kind of define in machines, it's really just an emergent property of information processing. So all that machines are doing is just doing information processing.
Mhm.
So in that case, are emotions becoming part of thinking for the machines, or are they just these kind of emotions, or thinking is just unique to only human biology or any other biology? So when this is becoming very important, because I mean, as you must have read also, that Elon Musk is that AI now, or that entity that they developed an algorithm that was, so they thought that it's so dangerous they cannot release it to public. So they were able to give that command to write it like a human, and it was able to write, and that they saw something in that they thought that it's not something that they can release in the public. So what is it in the algorithm that happens after you train the algorithm to do certain tasks, or to do some kind of information processing? What is it that happens that creates that security fear, that creates that this is something that we have to control? Because Facebook has gone through that, and these AI now, they have gone through that, and I'm sure there are many other researchers who are also observing similar pattern. So what is it
Right.
that happens? What is it that happens that creates that security risk in the algorithms that are being developed?
So let's take the case of the OpenAI algorithm that they recently, not algorithm, the model that they recently built, um, which is able to produce English-like language output, right? Um, End of the day, it is still a model that generates, it models a function that they have defined by saying, here is here are millions of lines of text, and this character follows whatever we have shown you so far, and you train on that, and then say, okay, now the next character is what follows. And what the algorithm is building is a probability distribution of what characters come after what has come so far. So it's building a map of when you see the words "this is," then after that there is a high probability that the proposition A will come. This is A. So it's a language synthesis based on probability distributions. And then once the model has learned this probability mapping, then they say, okay, we are going to uh, show it some text as the seed text that they show, and then the algorithm starts generating what it thinks are the most probable next set of characters. So that is how it generates text. There is no inherent risk involved in that kind of an algorithm in my mind. The only risk is the societal impact of it. The algorithm itself is benign. So in this case, I think what their risk assessment said is that, okay, here is a model that can generate text that seems like something that is written by humans. Now, once you have a tool like this, crafty people will use that tool for nefarious purposes and generate text that is either insensitive to some people, or fake news kind of text, or uh, just flood the internet with generated text so that algorithms like Google search that rely on human written text as an important marking in where to show the result in their search results, those kind of algorithms can get fooled now. So all these are sort of collateral risks that come about by using the model in insincere or malicious ways.
Sure.
The
No,
algorithm itself is not.
yes, I understand your point, and that's a fair concern. That's a fair concern that what is the going to be the impact on the society. Now, just like the algorithm is able to write like humans, and it blurs the boundaries between human writing and machine writing. We also have the speech that is
Right.
blurs the boundary between human speech or machine speech. Right now, when you are talking to Siri or Google or any other chatbot, then you just don't know whether you are talking to a human or a machine. So those boundaries are already blurred now. This
Yeah. Same with the auto-generated images of people's faces, for example, that are
exactly,
indistinguishable. Like they were easily distinguishable till about last year, but this year's results are so refined that one just cannot tell whether it's a machine-generated face or not.
very true, very true. That
So
is so true.
yeah.
So then the question is, Mol, that if we have these blurring boundaries between human and machine in speech, in vision,
Mhm.
in text, in writing, and perhaps in smell in the coming years, and then and if they are able to think, I think there's some sort of awareness is there already in machines. They're able to think, they're able to think about the commands, because you are giving them a command, just like you give a command to a kid or a student or to an employee to do certain tasks. You give a command to a machine, and the machine follows that command. So in that, with in those criteria, if we just evaluate from that perspective, then there is some thinking that when we give a command, it follows the command. So there is some thinking involved. So which are the mechanisms by which this consciousness is manifested in machine? Because as you see, I mean, while all these boundaries are blurring in speech, in writing, in image creation, and all in thinking abilities, we are also seeing that the bias is also emerging, from algorithms, as we see that so many, different kind of algorithms, whether it's for paroles or whether it's for which students will get into which college, admissions or interviews, all kinds of different algorithms, or the police where who should be arrested, or where which zip code will have more crimes. In all of those we are seeing bias emerging. So if let's say there is no thinking involved,
Mhm.
and machines just, the algorithms just follow the commands that is being written by researchers and creators like you, then how is this bias getting into that?
So the algorithms are written, though the intelligent seeming behavior that comes out of the models is because of the data. So as I was mentioning earlier, all of AI is, in a nutshell, based on finding out these probability distributions. So given that the probability distributions that these models learn are entirely based on the data that they have seen, then it is not a surprise that they would sort of continue predicting things that they have seen before, and that can be interpreted as a sort of a societal bias, but that is not anything that is malicious on the part of either the algorithm creator, nor the data, nor the model itself. It is the it is the interpretation that is giving that connotation.
But Amol, let me interrupt here. That I read recently somewhere that I'm not sure whether it was Siri or whether it was Google, but one of that gave a feedback that out of few astronauts, they don't like one astronaut. I'm not sure where I read that, but there was, some
Okay.
sort of feedback that, when the algorithm was interacting with the chatbot, Siri kind of that, it interacted with all the different astronauts, and one of them, it came back and said that I do not like this astronaut. So if an algorithm, I'm not sure whether this is true or not, but I read it somewhere. Now, there is
I
also,
haven't come across that.
yeah, so irrespective of whether it is true or not,
Mhm.
if a machine can develop that kind of feedback that I do not like this, like for example, we are just sometimes experiment with Google, the saying that thank you and all that, and then in response it says, it's just my job, I'm here to please you, and those kind of statements it makes. So when it makes those kind of statements, there is some sort of awareness. There is an awareness about not only internal environment but also about the external environment. I mean, when you ask them about, like we discussed before, the question about weather or where are you or location or things like that, the machines are aware about that, aware about the external, self awareness, that the how is the weather going to be, or what weather is, whether it's going to rain, or all those kind of questions. So there is that external self-awareness, and there is also internal self-awareness about.
Not really. No, sorry to interrupt, but
Sure.
there's no self-awareness at work there. So the way these personal assistants like Siri or Cortana, or Amazon, they work is that they have a speech detection engine that converts what you speak into text. There is a system that then figures out what the context is, and it literally has a bank of thousands of small programs. It decides which program to hand this text out to. So as soon as you ask, what's the weather like, then it it will select the weather app, forward that input to the weather app. The weather app will it will actually not give the text to the weather app. It would have already translated a command to the weather app saying something like today's weather, and then the weather app would return the data. It will get converted back to speech and sent out uh, to the to the personal assistant device. So it is far from having any awareness. You can do an experiment. um, you can easily fool these personal assistants.
Sure.
um,
That
right. I-
but Amol, how is this different than how we evaluate? If we ask, if I ask my son or daughter, that, hey, check the temperature. How is the temperature today? What they will do, they will go and look on the weather app. Or that is the similar kind of response we are getting from these machines. That when we ask them, the weather, they look at the weather channel like you just described. So how is that different? How is how there, I don't see any difference between how humans gather the information and how machines are gathering the information.
Indeed, in this example, actually, you're right that we follow similar kinds of steps to get to the weather data. Um, but these are factual questions,
Sure.
right? There is no self context as such in these personal assistants. Like, you cannot ask them, will you feel cold when you go outside today? Would you like to wear a sweater today? That's a highly personal question, and that has very little bearing on the actual temperature outside.
Yes, but because we have not made advances in the senses yet, that is the reason. In the coming years, there are advances happening. So they will be machines will be able to feel just the way we are able to feel. So whether machines will feel cold or hot, all those things will emerge in the coming years as the researchers are working on it. So those aspects, while they are not there, they
Mhm.
are under development.
Yes, they will again come as a utility. The machines will, so you can keep prodding the machines further and further towards subjective questions, and the machines will keep coming up short. Um, think about a question like this: do you think you have lived a purposeful life? And think about how far personal assistants are from answering a question like that. And it is kind of a situation where, yes, technology is sort of pushing the boundaries further and further, but at the same time, it is, you can think of it as a finer and finer grained simulation of the reality.
Yes, I hear you on that. But coming to your point about asking machines whether you have lived a purposeful life, now for a machine, a purposeful life is, what goals were defined for that machine and whether the machine is able to meet those goals. That is the purpose. Now, if you ask the same question to humans, have you lived a purposeful life?
Mhm.
I am not sure even most of the humans will be able to answer because they don't have those defined goals. So in those aspects, I think machine is probably more advanced and they have more clarity about what their purpose is, what their goals were, and or rather what their goals are, and whether they are meeting those goals, and the same kind of clarity. And is not there in humans. I mean, you ask, any number of humans, are you living a purposeful life? They just don't,
Right, right.
they cannot answer.
And that I mean, that is actually the beauty of the way humans think. In my opinion, yes, there is this lack of clarity, if you will, uh, but the lack of clarity is not because of lack of information or lack of ability to process. It is a lack of clarity because of the gigantic number of options that we are actually processing when trying to come up with that answer.
Most of
What?
the people are not even sure that they have a purpose.
True, but we for example have the ability to do counterfactual reasoning
Sure.
that, you know, had I done this, I would have been here, and those kind of sort of internal simulations and ability to simultaneously run those kind of simulations and coming to a feel of an answer, which may not be clear, but it has somehow taken into account all those tiny possibilities that you could have taken up. Uh, Sorry, all the possible paths that you could have taken up,
Oh,
right? So uh, those kind of things, I think machines are still pretty far away from, and whether that's a good thing or bad thing is up for debate. But I think getting machines to that kind of sophistication will be a good thing. In fact, as a defense against extremely advanced AI tools, um, in my mind, the traditional AI tools that we are developing right now, they're becoming so powerful that humans can start using them as as nuclear weapons, essentially. Like, imagine every household had 10 nuclear weapons stocked,
exactly.
right? Anybody can now, if um, even if OpenAI did not release the model, 2 years down the road, everybody will have a model like that, or will have access to a model like that. It's inevitable, right?
Okay.
So and humans are actually not capable enough to identify all these threats and risks and take continuous actions against them to protect ourselves. So, in fact, there we need more powerful AI systems which are not only tools but are actually able to make uh, make moral assessments of things.
Yeah.
So so and then we start going into uh, bringing consciousness to AI systems, which would be another way of saying that, okay, this system not only processes data as it comes in, but is actually able to independently assess the impact of the actions that it's about to take and act accordingly, or it is able to is able to monitor possible threats that are coming in and defend against them proactively.
Yes. No, very true. And at the point you just made, I wrote in my article that just came out today in Forbes that the democratization of this, development, and that the availability of computer that anyone can buy, all across nation is so cheap. Everyone can buy computer now, and the computing power everyone has access to. So the way the humans, or the nations rather, were controlling the weapons of mass development over the years was that they were just following where the money is going, because
Mhm.
every like nuclear weapons or everything required large infrastructure, and it required a lot of investment. But now the development of algorithms that could destroy or that could do damage, anybody can develop that. It
Yeah.
is the information is available. There is a democratization of development, and everyone has computer all across nation, everyone has internet connection. So how there is no way we will be able to control proactively? How would we know who is developing what algorithm? I mean, right now, if you look at the efforts that are being made for regulating AI, is that they are putting together privacy guidelines, they're putting together ethics guidelines, but how there is none of these are going to help us to manage the security risks that are emerging,
Mhm.
because there is all these unknowns of securities. We just don't know where they emerge. We just don't know where the threat is going to come from. So
Right.
is there a way that you all researchers that you all are working, that you can define that there needs to be certain code or there needs to be certain command in any algorithm that would, make that algorithm deadly or lethal. That, if we know that command, then we can perhaps, track that, in all the algorithm development across nations, and we can, give identity to all the algorithms, and we can create an algorithm that is like a tracker that just tracks that code in each and every algorithm that is being developed across nations or that is in public use. So is that something like that that can be developed? That's what I wanted to ask you, when I invited you to come on this counter, because as a researcher, that is something I want to know, that what kind of command you would put in an algorithm that would make it deadly, and if there is a way to track that.
Unfortunately, in my mind, there is no way to track usage of AI systems. The AI systems can completely live on someone's personal computer, disconnected from the internet, till they are ready to do their job. And given that these are tools, we will have to ultimately say that the person using the tool is the responsible party and not the tool itself. So the ramifications of using the tool in bad ways has to be criminal prosecution. I don't see any proactive way to go out and hunt for these usages before they happen.
But then, we are putting the security of the entire, humanity at risk, because if
Mhm.
if somebody develops that kind of algorithm and gives it a command that, go and destroy this, race or that race, or, go and create destroy all the weapons in this country, or go and, make all the weapons that are there, make them active, any kind of command,
Mhm.
then how, I mean, if any individual is able to create that kind of security risk for the future of humanity, and if we have no way to proactively know, then how are we going to manage the security risk coming to us in the coming years? Because that makes it, the fear and panic that is developing in the global community, that probably has, a valid base, then I think.
It is in some ways valid. And again, I want to clarify that it is not the AI tools that are being developed themselves that are a problem, but their use is going to be a problem.
Of course.
Uh, and so that is one of the reasons why I got into the line of work that I'm in, which is general intelligence, which is a general purpose intelligence system that you can give high level moral code to. For example, uh, Isaac Asimov famously has three rules of robotics, where he imagined all future robots being embedded with three simple rules, um, to protect any harm coming from them to humans. Now, to get to a robot or an AI system that can even process or understand those types of rules would require general intelligence. And that is why getting us quickly to an AGI system is so important in my mind, that it is our pretty much only potential safeguard against malicious use.
So, do you think that developing an AGI system, artificial general system, that could, where the computation would be such that, it can consciously go and, scan the internet, or scan all the IoT machines, or, scan
Mhm.
anything that is out there that is connected, that could have algorithm that could do any kind of damage? So, do you think researchers can create a system like that in the coming years, if not
Yeah,
now?
I hope so. Imagine if a human has access to the entire internet, um, and is able to actually focus on figuring out where anomalies are occurring everywhere in the internet, and have the computational capabilities to bring in that information and process it, then a general intelligent system like humans would actually be able to balance the resources in a way such that tiny hints of something inappropriate going on somewhere, you immediately focus more attention there, or you 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 are able to correlate systems that are far away and patterns emerging between systems. Those kind of threats, humans are really good at assessing things like that in our daily lives. A similar situation comes up in our daily lives. For example, we are crossing the road and we see a car coming in. Uh, we immediately are able to turn our attention to that object instead of the conversation we are having with our friend who's walking with us. So this ability to allocate resources very intelligently to the right set of problems in front of us, that is part of the AGI system of the future. And uh, I think that is the only way we can actually be able to computationally achieve any kind of deterrence.
Sure. I mean, let's hope so. But see, I still don't understand why we cannot create a system uh, in algorithm, like right now, not, of course, in coming years, hopefully we'll be able to do it, that can, detect the code where it says that go and kill any human, and across any nation. But there must be a code, like, you just said that, there were those three principles were defined, and in one of that principle is do no harm to, humans. But
Mhm.
in spite of that, we see the cyber warfare emerging, right now, that is automated, AI driven, and AI driven facial recognition technology, AI driven, autonomous weapons are developing. So all kinds of, systems are emerging that would harm humans. And
But
when
the harm is coming from humans who are using those systems, not the systems themselves. That's the distinction I want to keep going back to. If there is a rogue government who wants to use facial recognition to surveil its citizens, they can do it, and there's no conceivable way to stop the government from doing it unless the citizens object to it.
Sure. No, that's a fair point, Amol. But at the same time, let's say that if there is a drone uh, with, the command already there, that, if you see certain person, then, just the drone that it should go and, either whatever weapon it has to use that, but kill that, human being. So
Mhm.
in that condition, and as the autonomous weapons are being developed, the humans will get out of, the picture at certain point, because then, it will just follow the commands, once it becomes autonomous. Right now there is some sort of control by humans, because there, at certain point, humans are involved in that, but as it becomes autonomous, humans won't be involved in that. And, then the AI algorithm, and the command that it would just, with the drones or, any other weapon system, it can, go and kill any human, and we will have absolutely no control at that point. So when weapons become autonomous, and, at that point, how do we control these kind of scenarios?
We have to keep the humans responsible for deploying these weapons and tools. The same goes for autonomous cars, for example. The reason there is such a pushback against deregularizing and using autonomous cars right away uh, is exactly that. Like the systems are not in any way uh, holding themselves up to any moral standard. So a human must be held responsible for the actions of the systems. So that's why we don't want to easily let automated cars be on the road, because then the boundaries get really blurred in terms of who is responsible for that accident and a death of a pedestrian, for example. So that's the thing. The buck has to stop with the human who ordered that system up.
Yes. So, I mean, if you talk about autonomous cars, let's say, that there is another autonomous car on the road, and there is a human on the road, and now other autonomous car has to make a decision whether who to, save, whether to save the other autonomous car or
Mhm.
whether to save a human. So when those kind of questions will come, how will these, machines take a decision who to, who can it sacrifice, whether a human or a robot? So when those kind of questions will come, so how will these be defined in the algorithms or in the code, that how the machine should set the goal, or whether they should set a goal of killing another machine, or to save a human, or whether how this programming will happen, or how do you program all that?
We can definitely put some heuristics in the algorithms when certain situations occur and there's a risk assessment being done. Though at the end of the day, such predefined heuristics or rules are always going to fall short because reality is more complex than any rule can define,
Yeah.
right? So in fact, that is why we need to accelerate AGI research, because that is only with AGI we can tell the system, don't kill a human. There is no sort of conceivable way to put that kind of a logic into today's autonomous car, unfortunately.
Yes, Amol. I mean, I hear your case on why we need to rapidly advance towards AGI, but at the same time, think if you give a human-like thinking ability to a machine,
Hmm.
cannot even trust humans at this point. Humans are killing each other. I mean, how
Yeah.
many civilizations
Hmm.
destroyed themselves by just killing each other? As it's not like these technological advances are happening first time. It has happened in the past, and to control those technologies, the civilized nations have killed each other, and the civilization has been impacted. So when we are not the human, if we are trying to create machine with human like thinking ability, then we cannot even think, we cannot even trust humans. Look at the right now, just how many nations are living in peace, how much warfare is happening, and how much, I mean, we created cyberspace. It's a man-made world, and look at what is happening in cyberspace. Look at the number of cyber attacks and cyber crimes happening every single day. So now when we are adding AI factor to that, making it more intelligent, look at how it is advancing this year, the cyber attacks and cyber crimes, AI driven. So my question is that, I mean, yes, it's a good noble goal to have, create human like machines, with a human like thinking ability, but is that the right way to go forward? Because we want machines to think like humans? We have to figure out a way that we can control. Yes, we do need to advance intelligence, we do need to advance enhance memory, or enhance processing capability, or rapidly doing all these data analysis. We do need to develop all those things, because our goal is not just to stay on earth. We want to explore space, and we want to go beyond that. So there is a lot that humans want to do, and for that, yes, the assistance of machines, intelligent machines, would be very, very beneficial, because we can send them where we humans cannot go first, and there are a lot of things they can do. But at the same time, we do need to develop that control, and researchers like you can figure out what control to put in that, so that we don't end up killing the humanity at some point in the coming years.
Yes, yes. I mean that's a big question in front of AI community, and people are actively thinking about it. Um, there aren't any good solutions as such, as I was saying, but that doesn't mean solutions won't come forward.
Yes.
There are people working on it diligently.
people like you who are developing algorithms, you all can think, creatively. I'm sure, individually and collectively, if you all put your heads together, I'm sure you will come up with a way to insert that code in it that will, make sure that we don't destroy humanity. So that, I'm sure that is something, possible. But as in the research, what trends you are seeing for this, developing the consciousness or, thinking ability in computers or machines?
So the most human-like learning abilities that are coming up right now is through reinforcement learning, where the machines are the algorithm is taught by a distant objective, not something that comes up right away, but a game that it wins after 40 moves, or similar distant rewards. And that has allowed these algorithms to act more intelligently, compared to the earlier generation, where the algorithms were actually essentially looking one or two steps ahead. Now they are able to uh, plan for the future and anticipate certain things coming up. And so that is the biggest advancement that has happened recently and is happening. Uh, every year we see newer and newer uh, areas being conquered essentially by reinforcement learning based systems. AlphaGo is a good example. They recently uh, beat other games as well that were considered very, very difficult for AI to deal with. And so that advancement continues, and that will continue uh, at such a pace that I think within the next 5 years or so, we should have systems that are able to create robots, for example, that move fluidly. Because robotic control is a difficult problem to solve so far, and reinforcement learning has some really good uh, clues as to how to approach that kind of a problem. So in terms of having machines that are really useful for our purposes, like exploring space and things like that, where they can actually go to Mars, for example, and dig for minerals and process it and build a shelter for us, for example. Those kind of those kind of utilities uh, need fluid movement control and really advanced robotic control. So those kind of things are coming up. So I'm hopeful for that side of the future, and yeah, there's a lot of good work going on there.
That's good. I'm glad to hear that. Now, as you develop these kind of complex systems, and go towards this software synthesis, and as the software program complexity goes higher, as a researcher, do you still understand all the operations of the code, or it becomes too complex because it's not just simple one line code, right? I mean, it's a very complex,
Oh, we left that stop long time ago.
So
we
because the code becomes so complex, then how do you all go through, line by line?
so so uh, we actually haven't been understanding the deep learning or neural network type of models since 1960s. In fact, that was one of the biggest criticism that neural network type models had during the 70s and 80s, where people said that, hey, you're building these models and these weights are getting adjusted. They all just look like a bunch of numbers with no meaning associated with them. Sure, it produces some output, but we have no idea what's going on inside. And that was the biggest criticism that led to symbolic AI development, where AI systems were based on logic. So you actually have um, uh, programs that synthesize knowledge graphs to represent reality. For example, um, uh, he drank coffee is a situation. Then he is refers to a man, and coffee is like it refers to a drink, which is a food item, and there's actions that man can do, like literally decoding human knowledge into these kind of graphs and connections, and trying to represent those things in computers such that then you give computer a novel situation, it can try to step through these complex graph-like rules and connections and give you some result that is extremely traceable. Like you can literally take the result back and step through the knowledge graph, what connections it used, and all that, and you can actually understand what the system did. But neural networks are nothing like that. And neural networks is what is used in deep learning. And there is actually no good way to understand neural networks. Um,
Isn't that a cause of great concern then, that we don't know how that whatever is happening in the neural networks, that we just blindly trust that?
well, we trust humans. We don't know what's happening in our neural networks. It's the same thing.
We are already suffering with, why would create another intelligence that could, be a problem for humanity? Why?
So why use neural networks? That's a good question. There are many reasons, but I think the most interesting reason is that reality can only be tamed by neural network type representations. So reality is so complex that it cannot be decoded in a structure that we can read and understand. Reality is more complex than what humans can understand. So to put that as a requirement on algorithms, that they actually produce steps that we can understand, is severely limiting. And that's why people had to move away from symbolic AI pretty much, and nobody does it anymore, because reality is just too complex. We cannot represent it.
Yeah, but if we cannot trace, then that is a great problems, great security emerging there. So I mean, I don't think that the neural network should be the only way to go forward. I am sure that everyone can put together their heads and come up with a better way to develop that intelligence. We don't have to shift our goals. We just have to redefine how we are going towards that, so that we keep the control, because here I think we have already lost the control.
In a way, yes, yes. And that's I would say that's a price we pay for the power we extract out of AI.
For what? Price we pay for what? For
The
democracy,
having
for humanity?
Well, I mean, allowing AI systems to be black boxes is is a price that we have to pay if we want the black box to be powerful. If we want simple systems that we can understand, then we won't have all these advances in AI.
And that is not true, because I mean, look, we do want powerful intelligence, but we want intelligence that we humans can control. That is the only bottom line here. And the way we are going forward with these neural networks is that we have absolutely no control. Why create things that where we will have absolutely no control in the coming years, or when now we don't have control? So I'm sure there must be different ways by which we can, create more intelligence. I mean, this is not the only way. If we came up with, neural networks, I'm sure we can come up with something better that could, make sure that we are not impacting the future of humanity. But having said that, what would you like to tell our global viewers and listeners about your efforts towards developing machine consciousness, and what projects you're working on, if anything relevant you would like to say?
Yes, so I am looking into artificial general intelligence, as I was mentioning earlier, and consciousness. Approaching something like consciousness is an important part of building a general intelligence in my mind, because at the most sort of benign definition of consciousness, consciousness acts as a regulatory system uh, for humans to process and deal with enormous complexities of the world. And bringing that kind of capability in AI systems is, in my mind, the only way to get to human level general intelligence. And that's what I'm working towards.
Great. So thank you so much, Amol, for participating in Risk Roundup today. We
Thank
appreciate your
you.
insight on machine consciousness, and our global viewers and listeners will benefit tremendously from the understanding you provided on machine consciousness and what are the risks and rewards and promise and perils. So even if a single individual or entity is able to benefit from the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Thank you.
Wonderful. So Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence, and transformation happening across cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they all walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. And it is not possible to conceive any one of the three without the existence of the other two. All three concepts fit into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to other Risk Roundup webcasts, or listen to the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayashree, host of Risk Roundup, signing off. See you next time. Thank you.